All right, we're going to jump into 1.2, which talks all about similar triangles. So we're going to talk about angle measures, and we're also going to use our similarity to find lengths of triangles. So the first thing we're going to bring up is our vertical angles, which vertical angles share a vertex, but they're actually on opposite sides of each other. So the one thing we need for vertical angles would be two straight lines. So we're always having the two lines form an X. And then these are the ones across from each other. So 1 and 3 are vertical, and 4 and 2. Okay. The other big thing is that vertical angles are always equal. They have equal measurements, which means they are congruent to each other. Okay, just to remind you, we also talked about angles that if we had two parallel lines, if they were cut by a transversal, we could talk about different types of angles there. So the transversal, oh goodness. A transversal is the line that intersects two coplanar lines. So the transversal would be this line here. Okay. And we have corresponding angles that have equal measurement. We have angles that are what we call interior. So those are inside of the parallel line. So that would be like angle 3, 4, 5, and 6. We also have what we call exterior angles. Those are on the outside of the parallel line. So 1, 2, 7, and 8. And with these angles, we have different relationships. So we talked about our vertical angles, which we know are already congruent to each other. So make a note of that. Verticals are always congruent. We also have angles called alternate interior. So those words alternate and interior mean that they're on opposite sides of the transversal and they're interior. So they're going to be on the inside of our parallel lines. So in this example, this would be 3 and 6 and 4 and 5. These types of angles are always congruent to each other. All right, following along with the same kind of pattern, we have alternate exteriors. So these are on opposite sides of the parallel line. Again, that's what the alternate means. But this time they're exterior, so they're going to be on the outside of our parallel lines. Alternate exteriors are also congruent to each other. We also have angles that are called corresponding. So these are a little trickier because the word corresponding doesn't really give you a hint about where they're located. So corresponding are going to be on the same side of your transversal, but we're going to have one interior and one exterior. So one on the inside and one on the outside. And these are also congruent to each other. I'm going to change this since I said inside and outside before. I'm going to keep that same vocabulary going. So one inside, one outside, but same side of the transversal. And then our last one, these are called interior angles on the same side. So we also call these consecutive interiors. I've also seen same side, which is kind of what they're calling them here, same side interior. Okay, these are going to be on the same side of the transversal, obviously, because of the name. And they're going to be on the inside because they're both interiors. This is the only one that's different. All the other ones we've talked about already are congruent. This is the only one that's going to be supplementary, which means they would add to 180. Okay, and then just to talk about different types of triangles. So one type of triangle is called equilateral. So all the sides are equal to each other. And if all the sides are equal, also are the angles. So the angles and the sides are all going to have the same measurement. If two sides are equal, we call this isosceles. So equal, isosceles. And if we have two sides, we also have two angles. Congruent. And then our last one is scalene. Scalene means that none of them are the same. Okay, so going in line with that, we have what we call similar triangles. So similar triangles have equal corresponding angles. Okay, so they have equal angles, but their sides are different lengths. So back in geometry, these, when we made them get bigger, we called them enlargements. When we made them get smaller, we called them reductions. But both are just dilations, if I could spell dilation. Okay. Our other transformations kept them congruent, but when we had that size change, we have similar triangles. Okay. So then congruent triangles, everything about them is the same. Their angles are the same and they have equal side lengths. So it's almost as if you copied and pasted the same picture, but maybe this time you reflected it or you rotated it or you translated it. But it's the same shape, just in a different location. Okay. We also have right here, I want to emphasize this. So similar triangles have the exact same shape, so they have the same angles, but different side lengths. Congruent triangles are the exact same size and shape, so everything about them matches up and is perfect. Okay, so when we have similar triangles, like I said before, the angles are the same, but their side lengths are slightly different. So when we created similar triangles with dilations, we used what we called a scale factor. And we either made the shape bigger or we made the shape smaller. So for example, if we were given that, let's say B is 24 and A is 15, and C is 27, but all we know is that C is 9. Okay, going off this equation that we have here, we can set up these ratios to find the missing side. So we know that A is 15. We know that little a or A prime, we don't know that actually. B is 24. We don't know B prime. C is 27 and C prime is 9. Okay, so we can use the fact that we know that obviously to get from 27 to 9, the only piece that we know is we would have to divide by 9. Or not divide by 9, divide by 3. So if we take the other sides and we divide by 3, we could get that B is now equal to 8 and A would be equal to 5 once we find that scale factor. Okay, and so just to reiterate, similar triangles have the same shape and have corresponding angles with equal measurements. Congruent triangles are exactly the same, so all their angles match up and all their sides have a congruent piece too.